Tardes, profesor. Mi grupo y yo vamos a exponer acerca de la influencia del caudal en las pérdidas de carga en tuberías de plantas de tratamiento de agua. Mi grupo está formado por Arias Velázquez Nicole, mi persona, Eric Bernabé, Sebastián Amanso, Jefferson Vázquez y José Fabricio Llovera. Siguiente, por favor. Como introducción tenemos the supply of drinking. Water is essential for public health and sustainable default in water treatment plants, water flows, uh, through people's where head loss occurs, friction, the water people walls. One of my factor. Head loss is the flow rate. As flow rate is equinal, water velocity also increment results in rate energy loss here pumping cuts. Therefore, is study analyze the influence for rate in head loss in people once used in drinking water treatment plants. Siguiente, por favor.
General objectives to analyze the influence of flow rate on head-on loss in the pumping of drinking water treatment, plan throw-up, review and analyze of science literatures with the aim of understanding its effects on hydraulic efficiency and energy consumption of this system. Uh, Specific objectives. Identify the main hydraulic factors, examine the influence of the flow rate of pressure losses, analyze the application of the Bernoulli equation, the Darcy-Weisbach equation, the Coolbrooke-White equation, and the Reynolds number. Justify the importance of properly select the flow rate and designate the pipe hydraulic.
Not only have applied aerodynamic model to analyze water bodies, computational fluid dynamics más conversation equations and gestal equator have been used to evaluate water quality, comfort, and river behavior. These studies demonstrate that aerodynamic models are useful tools for water and resource management. En la international background, international studies show that heat loss in pipes mainly depends on flow rate, flow velocity, pipe diameter, router, and pipe length. As the flow rate increases, friction loss also increase. And the Darcy-Weisbach equation is widely used to estimate head loss, while proper hydraulic testing helps reduce energy consumption and improve the efficiency of drinking water treatment and distribution.
Theoretical framework, fluid properties built to people flow. Densities are unknown of mass contaminant in wide volume of fluid. It is expressed in GM. Flow rate is volume of water passing through a PP wide time. And pressure is for exercise by fluids on the walls in the PP for inch area. Siguiente. Bernoulli equation. The Bernoulli equation describes the relative pressure velocity elevated in flow fluid in real piping systems in the modified to include head loss caused in the friction. 15. In the equation is widely used analyze the hydraulic habit of water, the distribution, treating systems. Le doy paso a mi compañero.
The Darcy-Weisbach equation is one of the most widely used model for the calculation frictional heat loss in pipes. It also allows for estimation of energy loss during the fluid transport. About the Colebrook-White equation allows for the determination of friction factor in pipes with a turbulent flow, taking into account the Reynolds number and the relative roughness of the pipe. Uh, the Mood the Moody diagram is the graphic tool used to determine the friction factor base of the Reynolds number and the relative roughness of the pipe. It's used the simplified hydraulic analysis. About the Reynolds numbers, it's a dimensional parameter to use to determine the flow the regimen of the fluid within a pipe. Calculation it makes it possible to establish whether the flow is laminar, transitional, or turbulent. Uh, the next one gonna be ready.
And methodology and research approach. Descriptive, analytical, and documentary, based on review of scientific literature. Los materials, scientific articles from Scopus and Web of Science, and Seal of White, hydraulic and theoretical models. Methods, analysis of the conjunct equation, Bernoulli equation, Darcy-Weisbach equation, Colebrook-White equation, and Reynolds number and procedure, search in academic mm, database, selection of student based on inclusion criteria, extraction of key hydraulic information, comparative analysis of the selected studies. Le paso a mi compañero.
Various different studies about the influence of low rate of the bus loss. The results show that when the flow rate increases, the flow velocity also increases, and as your results, friction heat loss incident the pipes becomes greater in addition. A higher flow rate rating increasing the energy consumption of the pumping system, reducing the hydraulic efficiency of drinking water uh, treatment plants. Or why the study agreed the flow rate is one of the most important factors affecting the hydraulic performance of the system. Siguiente. Compares the main models used to analyze heat loss. The result shows that theoretical models explain the basic principles of fluid flow. Mathematic models should and Darcy, Weisbach, and Colebrook-White equation allow engineers to calculate heat loss, and experimental models verify this calculation under real operating conditions. Therefore, the review concludes can combine TC3 approach provides more reliable result for the hydraulic design of drinking water treatment plants. Siguiente, por favor. Eh, Tabla 3 present the main hydraulic variables affect due to loss. The results indicate that higher flow velocity. Increment friction, smaller piper diameters produce great energy loss. Larger pipers increasing flow resistance. Eager piper roughness increases the friction factor and turbulent flow generates more heat loss than laminar flow. Override the findings show that not only the flow rate but also the hydraulic variables must be considered to achieve a more efficient system with lower energy consumption. Siguiente.
Good afternoon. Next, I will present the discussion of the result obtained in this research. The result showed that flow rate is one of the main factors influencing head loss in the pipelines of the team after treatment plants. This happens because as the flow rate increases, the outer velocity also increases. One occur moves faster in it creates more friction when the inner or holes of the plane causing a greater loss of energy and a decrease in system pressure. These findings agree with the study conducted by Sunderland to 2022 put demonstrating that an increase in flow rate produces a significant increase in head loss and pressure loss. This confirms that flow velocity is a key factor affecting the hydraulic performance of pipelines. And the important finding is the influence of pipe diameter. When the diameter decreases under much flow but faster to carry the same amount of under. As a result, friction increases in leading to greater chaos. Therefore, silencing a broad range by diameter is essential for design in it. A finished hydraulic system. The study also analyze the phase of internal pipe roughness. Rougher pipe surfaces greater diameter resistance to water for increasing the friction factor consequently kilos. We highlight the importance of proper maintenance and selecting suitable by materials. In addition, by lens has the direct effect of headloss. The longer pipeline, the greater distance traveled by the water, resulting in more friction and a higher loss of energy. Finally, uh, the research showed that the flow linear also plays an important role. Turbulent interviolent for produces more this energy dissipation the laminar flow leading to higher head losing head loss. Overall, the discussion confirmed that head loss depends not only on flow rate but also on pipe diameter, by length, internal roughness of flow payment. All these factors should be considered when designing opening the team of their treatment plans to improve hydraulic efficiency. In conclusion,
As recommend, I recommend we should choosing the right flow rate to reduce heat loss and improve hydraulic efficiency. We also recommend using models like Bernoulli, Darcy, Weisbach, and Cullerbrook White to calculate heat loads and select the correct people diameter and pumping equipment. In addition, regular pipette maintenance improve to reduce rawness and prevent blockways. Final further study should include experiments of computer simulation software, sub-EPANEM or ANSI fluent to confirm test results and improving the design of drinking water treatment plants. Siguiente.
In conclusion, the main objective of this research was achieved, seeing it was confirmed that flow has a significant influence ahead of in the pipelines of the treatment of the treatment plants. The study also concludes that in conclude that that increasing the flow rate increases under velocity always increases friction. Inside the pipes, causing greater energy losses and lower system pressure. Furthermore, variables such as pipe diameter, pipe length, internal roughness, volume also have a significant impact on controlling performance. Therefore, these variables should be analyzed together to achieve a more efficient hydraulic design. The research also confirmed learnings in the shop. It could shock the dancing what is that equation the Goldberg high equation the Reynolds number are fundamental tool for analyzing fluid through and calculating the velocity under the distribution system. Fisher hydraulic design reduce energy consumption, lower operating costs, improve the overall performance of their treatment plants, ensuring safer and more reliable under supply. Thank you very much for your attention. I will be happy to answer any questions.